Okay, in this video, I want to go over how to factor by grouping. This is just another method for factoring quadratics. I'm going to go over 3 problems and do it by grouping in each one. Here's our first problem. We've got 12x squared plus 16x minus 28. The very first thing we want to do before we do anything, no matter what method of factoring you're using, the very first thing you always want to do is see, are all of your terms divisible by the same thing? So we've got 3 terms here. These 2 right here, they both have x's, but this one doesn't, so they're not all divisible by x. However, if you look, these are all even numbers, so they're all at least divisible by 2. So that's good. Let's see if there's a bigger number. Let's see, 4 will go into all of them. And 8 will go in, well, 6 will go into 12, but it won't go into either of these 2 numbers. So 4 is going to be the biggest number we're going to get. So first off, let's factor out a 4. So I'm going to divide out a 4 from each of these. So 12 divided by 4 is 3, 16 divided by 4 is 4, and 28 divided by 4 is 7. And I can check to see if my answer is right, if I factored this correctly, pulled out that common factor. If I just multiply that 4 back through, I should get that same answer, and I do, so I'm okay. So now let's talk about how to factor by grouping. My next step, or my first step anyways, with factoring by grouping is I'm going to take, well, I guess let's better explain some. Let's talk about standard form first of a quadratic. So standard form of a quadratic looks something like this. So I've got, standard form is taking all of your terms and listing them in order from highest exponent to least highest exponent. Okay. Well, I don't like that color. Let's not use that color. Let's see, is green. Green's a good color. There we go. Okay, so this is standard form for a quadratic. Notice I've got 3 terms. They're in order from from highest exponent to least highest exponent. So this is degree 2, my degree 1 term. This is my constant term. Okay, and A, B, and C in this case, they are my coefficients. So this is whatever number's out in front of my variable squared term, this is whatever number's in front of my linear term, and this is my constant value. So just, for example, over here, 3, right here, the number positive 3 is going to be my A value, positive 4 is going to be my B value, and negative 7 is going to be my C value. Now, if these were all mixed up, like let's say I had 4x first, and then negative 7, and then positive 3x squared, my A, B, and C values have not changed at all, because my A value is still the value in front of my x squared term. My A value is still positive 3, my B value is still positive 4, and my C value is still negative 7. Okay, so even though they're not in standard form with highest degree listed first, these are still my A, B, and C values. Now, the reason why I bring that up is because the very first step I want to take in this problem is I want to multiply together my A value and my C value. So in this case, it's going to be 3 times a negative 7, and that gives me negative 21. Okay, so that's my first step. I want to multiply my A value to my C value. Now what I want to do is I want to come up with every single factor I can think of, or pair of factors that multiply together to get 21. So let's see, that's 1 and 21, that multiplies together to 21, and 3 and 7, and that's it. Now what I want to do is I want to see which pair can I use through addition or subtraction to get the middle term, my B value, 4. Well, 1 and 21, if I add them together I get 22, if I subtract them from each other I get 20. 7 and 3, if I add them together I get 10, but if I subtract a negative 3 from a positive 7, I end up with a positive 4. Okay, so I want these signs on my 2 numbers because that gives me a positive 4. I do also want to check to make sure that negative 3 times a positive 7 still equals negative 21, and it does. And then, since our variable that we're dealing with is an x, I'm going to stick an x on both of these. Okay. Now, here's what we're going to do. If I were to simplify this right here, I would get 4x. So this is identical to 4x. They're interchangeable. So what I'm going to do is I'm going to rewrite this whole problem over here, except for instead of writing 4x, I'm going to write this. So here we go. I'm going to copy that 4 down. It just gets copied down the whole time. We got 3x squared, and then instead of that plus 4x, I'm going to write this. So minus 3x plus 7x, and then copy down my negative 7. Okay. Now, if I were to simplify this by combining like terms, I would add those together, and I'd get that same middle term right there. So, this is still the same equivalent to this expression right here. But I don't want to do that because that would undo all the hard work that we've gone through so far. What I want to do is now what we call grouping. So I've noticed I've got 4 terms here. I'm going to look first at the first 2, and then I'm going to look at the second 2. Okay, and I want to factor out a common factor. So let me copy down my 4 here again. Okay, then I want to look at these and say, okay, what can I pull out of these? What do they have in common? Well, they're both divisible by 3 and they're both divisible by x. So I'm going to pull out a 3x, and that leaves me with x minus 1. Okay, now I want to do the same thing over here. These two, they're both divisible by 7. So I'm going to pull out a positive 7. I want to make sure I put that plus sign there. That's important. And what I'm left with is x minus 1. Now, if you do this right, this right here, what's left over in both of those cases, they should be exactly identical. If they are not, then we've done something wrong, or we need to pull out a negative along with our value or something like that. But these two things have to be identical. That's important for our next and final step. So what I've got here now is I've got this expression right here, or that term right there, and this term right here. And they both have an x minus 1 in common. So what I'm going to do is that's going to be my common factor of these two terms, and I'm going to pull that x minus 1 out. So that leaves me, I've got that 4. I take out the x minus 1, and that leaves me with 3x plus 7. And now we are completely factored. We're down to 2 linear, degree 1, factors and a constant factor. Now let me just explain this part right here in case it kind of was confusing. Let's say I have some a value times some b value plus some c value times some b value. So in this case, what can I pull out of these? They're both divisible by b, so when I pull b out, I'm left with my a plus my c. Okay, it's essentially what we just did up here. This is my a value, right here is 3x. This is my b value, plus this is my c value, times the exact same thing right here, right? So what I'm doing is I'm pulling that b value out, there it is right there, right? And I'm left with my a value, 3x, plus my c value. So it is essentially the exact same thing as I'm doing right here, except for I'm just doing it with a binomial instead of a monomial, which can be kind of weird. But anyways, that's how you factor, by grouping. So just to recap, first thing you want to do is pull out the common factor, which we did here by pulling out a 4. Then we want to take our a value, which is the coefficient of our quadratic term, and times it to our constant term. And then we want to factor that number. We want to find a factor pair that through addition or subtraction combines to make my b value. And then I want to swap that pair for my b value, giving me something like this. And then I group first 2 together, pull out a common factor, second 2 together, pull out a common factor. Then if everything's right, whatever's left over out of both of those common factors should be identical. I can now pull that out, and I'm left with 3x plus 7, or I'm left with those things right there, and there's my final answer. Okay, so let's try another one. Okay, so here's a new one. We got x squared plus 11x plus 10. First thing I want to do is check to see, are they all divisible by the same thing? And in this case, they are not. There's nothing, well, the highest value I can pull out of all these is a positive 1, which doesn't do me any good. So these two are both divisible by x, but that one's not. And 11 and 10 don't have any common factors other than 1. So we can't pull anything out. So our next step is to take our a value, which in this case is a positive 1, right? That's the coefficient of x squared, times our c value. So 1 times 10 is, 1 times 10 is 10. And then I want to factor 10. So I got 1 and 10, or 2 and 5. I want to pick the pair that can add or subtract to make 11. That's going to be 1 and 10 if they are both positive and they both need an x on them. And now 1x plus 10x is 11x. I can now swap this for these. So I come over here, I rewrite it. I've got x squared, And then instead of plus 11x, I'm going to write plus 1x plus 10x. And then my plus 10 again. Okay. Next, I group. So I look at the first two, look at the last two. What can I pull out of these? I can pull out an x. It leaves me with x plus 1, right? X squared divided by x is x. X divided by x is 1. Then out of these, I can pull out a positive 10, leaving me with x plus 1. So I look at these again, I group again, this, or kind of group-ish. I look at the common factor out of both of these terms. I can pull out an x plus 1, and it leaves me with an x plus 10. And there's my final answer. Now I want to do something just really quick with this one. What would have happened, so I'm going to do it over here, whoops. What would have happened if, let me get down to this step, what if I had put these in a different order? Is that going to make a difference? So instead of putting it as plus x plus 10x, what if I did this? What if I said x squared and then plus 10x plus x? Is that a problem if I have like the highest coefficient listed first instead of the lowest coefficient like I did over on this one? Well, let's see. Out of these two, what can I pull out? The only thing I can pull out is an x, and that leaves me with x plus 10. Out of these two right here, they don't have anything in common, or I should say the highest thing that they are divisible by is a positive 1. And with this method, this grouping method, when you get to this stage, you always have to factor something out. So since these two, the only thing they are divisible by is a positive 1, that's exactly what I'm going to factor out. So I pull out a positive 1, leaves us with x plus 10. Okay, I definitely want to write that x plus 1 right there. It will be very important on the next step. Next thing I want to do, I'm pull out those x plus 10s, and that leaves me with x plus 1 as my final answer. And you'll see these two answers are actually the exact same thing. It's just my factors are written in a different order, and that is totally fine. Think about one of the properties of multiplication. If I have 2 times 4, that's equal to 8. If I switch it around and do 4 times 2, that's also equal to 8. So that's a property of multiplication. They can be written in whatever order you want them to be, and it is still the same answer. So you might get this answer, your neighbor might get this answer, and you are both absolutely correct. Okay, here's our last problem for this video. 30b squared plus 93b minus 42. All right, so the first thing we want to do is see if they are all divisible by the same thing, and in this case, the highest number they are all divisible by is a 3. So I'm going to factor a 3 out. That leaves us with 10b squared plus 31b minus 14. Okay, next step, we'll take our a value, which is 10, and multiply it to our c value, which is negative 14, giving us negative 140. So this is what we want to factor. So let's take a look at this. What multiplies together to get 140? Well, we got our obvious one, 1 and 140. It's divisible by 2, so 2 and 70. It's not divisible by 3, but it is divisible by 4. 4 and 35. We got 5 and 28, 7 and 20, and 14 and 10. Okay, so that's all the things that 140 is evenly divisible by. I'm looking for a pair that will get me positive 31. So I look at all of our options here, and there is my winner right there, 4 and 35. So I need a negative 4 and a positive 35 in order for this to work. So my variable I'm dealing with is a b. So there we go. Now, kind of going back a little bit, once I got to this point, once I found this one, I knew it wasn't going to work because I add those together, I don't get 31. I get this one, I know that one's not going to work. As soon as I got to this one and I see it's going to work, I don't have to find any more. I found the pair that works, and none of the other pairs are going to work. So as long as my signs work out just fine, negative 4 times a positive 35 is negative 40, and they combine together to make positive 31, I'm good to go. So here we go. I'm going to replace this guy with those. So I've got 3 times 10b squared minus 4b plus 35b, right? Replace this with these, minus 14. Now we'll group, take a look at those two, see what they're divisible by, take a look at those two, see what they're divisible by. I'm going to copy that 3 down. So take a look at these. They're both divisible by b, and they're both divisible by 2. So I can pull out a 2b. And that leaves me with 5b minus 2. And on these ones, they are both divisible by 7. And keeping in mind that whatever I get out of this, when I pull that 7 out, I need it to the signs to remain the same. I need the 5b to be positive. I need the negative 2 to be, well, I need the 2 to be negative. So if I take 35 and divide it by a positive 7, I get positive 5b. So it is a positive 7 that I want to pull out. And then 14 divided by negative 14 divided by a positive 7 is negative 2. So now, copy our 3 down, pull out our 5b minus 2, and we pull out, that leaves us with 2b plus 7. And there is our factored form. One thing I just want to mention really quick, the importance of pulling that 3 out at the very beginning. This right here is the hardest part of factoring by grouping, in my opinion. Trying to, especially when this number right here gets kind of big, you can get a whole lot, there's a whole lot of things that will probably divide into it. And sometimes it's kind of hard to find that pair that actually works. So imagine for a second, we multiplied 10 to 14, got 140. But that was after we pulled this 3 out. If we didn't pull that 3 out, I would be multiplying 30 to negative 42, which is just fine. I'm still, going to be able to factor this thing down, but 30 times 42 is 1,260, and I would have to be factoring that to find something that adds together to get 93. So that first step of factoring out the common factor is really, really helpful in making these problems a lot simpler, because this right here is the hardest part, and if I have to deal with a large number and there's no other way, there's no other way around it, then it might take a lot longer of time. So just something to keep in mind. Always remember to pull out the common factor if you can.